So that's the next thing that I want to discuss quickly, quadratic functions. So first of all, you need to know how quadratic functions look like graphically. There are two shapes that you have, right? U shape or an N shape, upward facing or downward facing, or smiley face or sad face, however you're done it. Okay, दरवाजे बंद है पीछे से. Okay. The standard quadratic function is of this form: y equals ax squared plus bx plus c. Okay. When do you get the upward facing curve? When a is positive, and when a is negative, you get a downward facing curve, right? Now, in this function, in the standard form, c represents the y-intercept, right? When you input x equal to 0, you're just left with c. Okay, this is one form of quadratic function. You need to know how the graph looks like. For instance, if you have this quadratic function, a is 1, b is -4, c is -21. Since the coefficient of x squared is positive, it's going to be like this. And since this constant term is -21, the y-intercept is 0, -21. Is that okay? All of you know this, right? Okay. Now, if you have to find x-intercepts, you put y equal to 0 and solve quadratic equation like that. Again, you've seen this before. Now, this is important. Y equals ax squared plus bx plus c. That's the standard form of a quadratic function. Sometimes they give you equations in this form instead. Okay, so for example, you could have y equal to -2 into x plus 7 into x minus 3. Now, if they ask you for the x-intercepts of this function, what are they going to be? X-intercepts of this function? -7 and 3. We can write down the x-intercepts directly here. Okay? When you have a function of this form, we can write down the x-intercepts directly, because x-intercepts आप कैसे निकालते हैं? You put y equal to 0. When you put y equal to 0, that leaves you with -2 into x plus 7 into x minus 3 equal to 0. X equals -7 or x equals 3. These are the values that you get from this. So in this form, you can write down the x-intercepts directly. Okay? Is it an upward sloping curve or a downward sloping curve? It's a upward facing curve or a downward facing curve? Downward, right? N-shaped hogi. Why? Because this number is -2. This number is the same. This a here is the same as this a. The coefficient of x squared that you have here, this is the same a as that. So from y equals ax squared plus bx plus c form, these a values are the same. So since this number is negative, it's a downward facing curve, N-shaped curve. All right? Okay. How do you find the turning point of a quadratic function? Now, there are different names that you need to know about. For a quadratic function, the turning point is known as the vertex. It's also known as the turning point. And sometimes it's also known as the stationary point. And then depending on whether it's a U-shaped curve or an N-shaped curve, you can also call it a maximum point or a minimum point. Okay? These are different names for the turning point. If you have a U-shaped curve, for instance, this is the turning point. This is also going to give you the axis of symmetry of this curve. The curve is always symmetrical, quadratic curve. And this is the line of symmetry. This is the line of symmetry of this function. Okay? Now we have a formula that we can use to find the x coordinate of the turning point directly. And what's that? That's minus b over 2a. Again, another formula that I would recommend you to memorize, minus b over 2a. You can find the x coordinate of the turning point using this formula. X equals minus b over 2a. So for instance, if you have that same function as before, let's say x squared minus 4x minus 21, x squared minus 4x minus 21. And you had to find the x coordinate of the turning point. You can use this formula, x equals minus b over 2a. So it becomes x equals minus 4 divided by 2 into 1, which is 2. This is the x coordinate of the turning point. Is this all right? Any problems? How do you find the y coordinate then? Put this back in the function and you get the corresponding y coordinate. You have the x value, just put that back in the function, you get the corresponding y coordinate. All good? So in this form, you can find the turning point directly like this. So when you put this back, you get a y value of minus 25. So this is the turning point of this function. Does that make sense? No problem? If you had this function instead, in the intercept form, can you tell me the turning point of this function? What's the turning point of this function? If you have a function in this form, what is the turning point going to be? Any idea? No? Is there any way to find the turning point? Is there a long way of finding this? What's that? Simplify, multiply करके simplify कर ले, minus b over 2a use कर ले. That's one possibility if nothing else works out. But can we just do it directly from here? Yes. Remember, it's a symmetric curve. Quadratic functions are always symmetrical. This curve is going to be like this, right? We have already found the x, and we already know the x-intercepts just by know what the x-intercepts are going to be, right? What are the x-intercepts? Minus 7 and 3. So we can have the x-intercept, x-axis like this, minus 7 and 3. Now, since the curve is symmetric, this turning point is going to be in the middle of minus 7 and 3. And that's always going to be true. The x coordinate of the turning point is always the midpoint of the x-intercepts. Okay? What's the midpoint of minus 7 and 3? Just add those two numbers, divide by 2, minus 7 plus 3 over 2, and that gives you minus 2. So the x coordinate of the turning point of this function is supposed to be negative 2. So if you know the x-intercepts, you can just average them to find the x coordinate of the turning point. Is that all right? So you should be able to figure this out directly from this form as well. Okay? ताकि simplify नहीं करना पड़े, उसमें time नहीं लगे. You can just write it directly from here. No problems? If it's simplified form, you use minus b over 2a. Okay? If it's this intercept form, just add up the x-intercepts, divide them by 2. Okay? For finding the x coordinate of the turning point. Okay, so that's the summary. If you have a function like this, you can find the vertex, you can find the axis of symmetry, right? If the curve is like this point has an x coordinate of 2. So the axis of symmetry, this line, it has an equation x equals 2. X-intercepts, put y equal to 0, find the x-intercepts. For y-intercept, this is just minus 21. All right? Make sense to everyone? Okay. Let's have a look at this quickly now. What's the value of x when f of x reaches its maximum? Seven, right? The x-intercepts are going to be 1 and 13. What's the value of x at which you have a maximum point? What they're asking for is the x coordinate of the turning point, right? X coordinate of this point. Just add these two up, 1 plus 13 divided by 2, and that gives you 7. That's the x coordinate of the turning point. Make sense? Okay. This is another form of quadratic function that you should be familiar with. This is called the vertex form or the completed square form. A into x minus h whole squared plus k. This is the third form that you need to be familiar with. Ax squared plus bx plus c. And then that intercept form, x minus something, and then x minus something else, right? This is the completed square form. You also have to be familiar with this. If you have something in this form, a into x minus h whole squared plus k. This number is going to be the x coordinate of the turning point, and this is going to be the y coordinate of the turning point. So if you have x minus 2 whole squared minus 25, the vertex is 2 and minus 25. Okay? So how do you find the x coordinate in this form? ये जो भी bracket के अंदर हो, you just put that equal to 0. What's the value of x that you get? 2. And this number outside, this is going to be the y coordinate, which is minus 25. So the x coordinate is found by putting this thing equal to 0. The y coordinate of the turning point is just the number that's written outside. That's the y coordinate. Is this all right? No problems? You need to remember this form as well. Sometimes you have functions given in this form and then they ask you for the turning point. It should not require any working. You should just be able to look at it and write down the turning point. Okay, now let's take a couple of examples. Let's say you have minus 4 into x plus 3 whole squared minus 14. What's the turning point? What's the turning point? क्या होगा? Put this equal to 0. What's the value of x that you get? Minus 3. And then the number outside, that's the y coordinate, minus 14. Is it a maximum point or a minimum point? Is it a maximum or a minimum? It's a maximum point because it's an N-shaped curve. Right? So it's a maximum point. Achha. Let's say you have 5 into 2x plus 8 whole squared plus 3. What's the turning point of this? जो ब्रैकेट के अंदर है उसको 0 से इक्वेट कर दे. 2x plus 8 equals 0. That gives you x equal to minus 4. Okay? And then the number outside, that is 3. That's the y coordinate. And this is a minimum point. it's not the standard form because you have a 2 here as well. So you can't just say it's -8. You have to put that thing inside the bracket equal to 0 and find the value of x from that. Ye clear? So from this form, if you have to find the x-intercept, x coordinate of the turning point, you say x minus h equals 0, x equals h, and this is the y coordinate, y equal to k. Again, you need to remember this. All right? Okay, now another important thing. Remember when we solve a quadratic equation, we get this thing like this, minus b plus minus square root of b square minus 4ac divided by 2a. Now, this expression, b square minus 4ac, this is very important. It is very significant in quadratic functions because this is what decides how many solutions a quadratic equation is going to have. B square minus 4ac. Okay? Let's say we have a curve like this. There are 3 possible positions it can be at with respect to the x-axis. One possibility is it intersects the x-axis at 2 points. Okay, this is one possibility. When a quadratic function intersects the x-axis at 2 points, remember, b square minus 4ac is greater than 0. This b square minus 4ac has this name, discriminant. So whenever we refer to discriminant, this is what it means, b square minus 4ac. When you have two x-intercepts, 2 points where the curve crosses the x-axis, b square minus 4ac is greater than 0. Is that okay? How many of you have seen this before? You look A1 mein, are you doing maths? All of you? No? Okay. Quadratic function mein, if you have a quadratic function of this form, y equals ax square plus bx plus c, if b square minus 4ac is greater than 0, you get 2 solutions, 1 and 2, 2 different solutions. Okay? Sometimes you have the curve like this, that it just touches the x-axis. In this case, b square minus 4ac is equal to 0. It's just touching the x-axis like this. And then the last case is where b square minus 4ac is less than 0. That is when the curve does not intersect the line. Is that okay? So whenever b square minus 4ac is greater than 0, you get 2 real solutions, 2 different solutions. Whenever b square minus 4ac is equal to 0, you get 1 real solution. You'll have a repeated root. One root will be coming twice. Like in this equation, if you have 16x squared plus 4x plus 1 equal to 0, when you factorize this, you get 4x plus 1 into 4x plus 1 equal to 0, and that gives you x equals minus 1 over 4 and x equals minus 1 over 4. The same number comes twice. That's one solution. The curve just touches the x-axis. And then the last case is when b square minus 4ac is less than 0. When b square minus 4ac is less than 0, you see what happens in the quadratic formula. Inside the square root, you have a negative number. You cannot evaluate this. So you get no solutions in that case. Is that okay? You need to remember these 3 different cases. Greater than 0 means 2 different solutions. Equal to 0 means 1 solution. Less than 0 means no solutions. Make sense? Now, let's look at this. How many distinct real solutions does this function have? How do we think about this? We would say, let's find b square minus 4ac. Okay. B is 10. So 10 squared minus 4 into a, which is minus 3, into c, which is minus 7. This evaluates to 16. Since 16 is a positive number, we say it has two distinct solutions. Okay? Distinct means different, two different solutions. All right? So b square minus 4 tells us how many solutions we are going to have for a quadratic function. No problems? Let's have a look at this example. Can all of you take 30 seconds and figure this out? In this equation, c is an integer constant. If the equation has no real solution, what's the least possible value of c? If a quadratic equation has no solution, what does that mean? If a quadratic equation has no solution, that means b square minus 4ac should be less than 0. Okay? How can you find the least possible value of c now? Try this first. It's not a quadratic equation that you get. It has no real solution. So b square minus 4ac should be less than 0. That means 12 squared minus 4 into 2 into c. It should be less than 0. What does that give us? 144 minus 8c is less than 0. 144 is less than 8c. 144 over 8. What's that? 18. 18 is less than c, or c is greater than 18. What's the value of c that we write there now? It says c is an integer. Since c is an integer, the least possible value of c would therefore be 19. That's what we write down. Is this all right? Yes. उसने क्वेश्चन में कहा हुआ है c is an integer constant. अगर वो नहीं कहा होता फिर तो जरूरी नहीं था. Then it could be 18 point something as well. But the question says it's integer and it's greater than 18. What's the least value greater than 18? 18 के बाद सबसे पहला नंबर 19 ही आता है integers में. All right? No problems? Okay, let's try this. Y equals x plus 5 and y equals x squared plus 11x plus c. System means this set of equations, the set of simultaneous equations. It has one distinct real solution. That means there's only one solution. What does that mean? One real solution. B square minus 4ac is equal to 0. Okay? But for using b square minus 4ac, we need the expression in this form. Need the equation in this form. Ax square plus bx plus c equal to 0. Only then we can use b square minus 4ac. We don't have that form right now. How do you convert it to that form, first of all? We first equate them, right? Because they're saying this line and this curve, they have only one solution. That means there's only one point where they meet each other. How do you find points of intersection of any two functions? We equate them. So that's how we start the process. We start by equating them, first of all. So we say x plus 5 equals x squared plus 11x plus c. Okay. Now we convert it to the standard form, ax squared plus bx plus c equal to 0. Take all terms to one side and have only 0 on the other side. What does that become? X squared plus 11x minus 1x, that's 10x, plus c minus 5 equal to 0. This is what we have, x squared plus 10x plus c minus 5 equal to 0. And now we know this equation is supposed to have only one solution. Since it's supposed to have one solution, b square minus 4ac is equal to 0. Okay? For quadratic functions, two solutions means greater than 0, b square minus 4ac greater than 0. One solution means b square minus 4ac is equal to 0. No solution means b square minus 4ac is less than 0. Only for quadratic functions. It does not work anywhere else. Only for quadratic functions. Okay, so now we say b square minus 4ac is equal to 0. That means 10 squared minus 4 into 1. What's c? In place of c, we've got this whole thing, right? The constant is c minus 5. And that gives you 100 minus 4c plus 20 equal to 0. And the value of c is 120 over 4, which is 30. That's the value of c that we're looking for. No problems? Okay? Okay. Okay, just a couple of more minutes before we have a break. A parabola with equation y equals x squared plus 5x plus 5, x squared plus 5x plus 6. Okay, by the way, what's a parabola? These shapes are known as parabolas as well. Okay? The quadratic graph shape, its name is parabola. Okay? A parabola with this equation intersects a line at exactly one point. If the line has this equation where a is a positive constant, what's the value of a? How do you approach this? Again, equate them first of all. X squared plus 5x plus 6, that equals ax minus 10. Okay? Now convert it to standard form, take all terms to one side, so it becomes x squared plus 5x minus ax plus 16 equal to 0. Remember, we want this form, ax squared plus bx plus c equal to 0. Coefficient of x squared is 1. What about the coefficient of x? What's the coefficient of x? What is the coefficient of x? X का coefficient, not x square का coefficient. X का coefficient क्या है? We'll have to take x common, and that leaves us with 5 minus a. So this is the coefficient of x then, 5 minus a. Is that okay? So we can say a is 1. In place of a, we put 1. In place of b, we put 5 minus a. And in place of c, we put 16. In b square minus 4ac, b square minus 4ac should be equal to 0. Right? Because there's only one point where they intersect. There's only one solution that they have. So we get 5 minus a whole squared minus 4 into 1 into 16, that is equal to 0. Now you solve this equation. One way to solve this is you take this to the other side, and that gives you 64. Take square root on both sides. When you take square root on both sides, that gives you 5 minus a equals plus minus 8. So that means either 5 minus a equals 8 or 5 minus a equals minus 8, a equals minus 3, or a equals 13. Now the question says a is a positive constant. That means a is equal to 13. That's your answer. Is this all right? Okay, so you have to be familiar with these three different forms. And you should be able to find the x-intercept from all of those forms, y-intercept, the turning point, without having to convert it to another form. Because if you have to convert it to another form, then it will take longer. So you should know about how to find x-intercepts and the turning points from each of these forms directly. Okay. Sum of roots is minus b over a, product of roots is c over a, and then you need to know about these three different cases of discriminant. B square minus 4ac greater than 0, equal to 0, less than 0. You have two solutions, one solution, no solution respectively. Okay, let's have a 5-minute break and then we come back.